Saxon Lab, our goal is to develop technologies and tools to improve transportation. And we want that to be more than just research that sits on a shelf and gathers dust, but we actually work to develop solutions that enable engineers to better operate their facilities. I think one of the areas that I've been most impressed with USDOT is their forward-thinking approach with connected vehicles and knowing that operators have existing systems, equipment, and hardware, and that being able to accommodate these new technologies is going to require some translation there and levels of integration. And so for more than 5 years, they've been working on the development of software to manage that with V2I Hub, software to facilitate the communication between these future connected vehicle hardware and then their existing systems. So what I'd like to do is provide a quick overview of what V2I Hub is. Why did USDOT develop it? How can it be helpful for operators? Where can information be found? And then what's the roadmap for it and any future functionality? So what is V2I Hub? Essentially, it's software to simplify the integration by doing this translation between different standards and protocols. It's a modular platform that can use an unlimited number of plugins to add functionality and communication. So it's not unlike a cell phone platform such as Android, where you have that platform and then you can add different apps or plugins that then add functionality or communication. It's essentially a software middleware that runs on an underlying operating system, which is Linux. And then as software, it was purposely designed to be flexible, so it can operate on a variety of roadside equipment to best meet operators' needs. And so that means it could run on the processor of the roadside unit, on a traffic signal controller coprocessor board, or a standalone industrial computer. By using a variety of plugins, you can essentially generate the SAE compliant messages for broadcast. Basic safety message, map, SPaT, traveler information message, position correction, and even future messages as they're developed or needs arrive.
Chris, sorry to interrupt. We're having a little bit of hard time hearing you. Your volume is kind of low. Is it possible for you to speak up a little bit?
Sure. Is that better?
Yeah, much better. Thanks.
Great. So using these plugins, that enables communication with different equipment and systems. And so V2I Hub has plugins that can connect to the DSRC radio, can communicate with the traffic signal controller, transportation management center, utilize GPS radios for position and for timing. It can also connect with position correction equipment or internet-provided data. At Turner Fairbanks here, we have it connected to a dynamic message sign where it can receive the basic safety messages from vehicles, determine if they're traveling above a speed threshold for a curve, and then automatically generate a warning and send it out NTCIP 1203 to a dynamic message sign to give a visual warning. And then you can connect to other equipment and sensors like road weather, pedestrian, internet, or specialized equipment. And then plugins can also be developed to add functionality and run connected vehicle applications, such as a conflict monitor to make sure that SPaT and map are matching and that it's matching with the traffic signal controller. Multimodal intelligent transportation signal system is actually in process and being added to the V2I hub as a variety of plugins to add that functionality. Curve speed warning is one of the applications I mentioned that we have running here, and then we actually use V2I hub to conduct hardware-in-the-loop research where we use VSIM modeling and we receive basic safety messages from an automated vehicle and vice versa, and so we can both track automated vehicles in VSIM, but then we can also broadcast simulated vehicles and have the automated vehicle respond to those. So what are some of the advantages to this, and why was it developed to help operators? And so some of the first are to reduce the obstacles for integration by being able to provide plugins that enable them to do the translation between both new hardware and their existing in a way that's scalable, efficient, and flexible. V2I Hub also provides a secure remote access for monitoring and configuration, and so that way to be able to access the equipment or upgrade the firmware or to modify settings, you can do it remotely instead of having to go out into the field. And then it's also been designed to be cross-cutting, both with the existing equipment but also future technologies such as automated vehicles. Documentation has been prepared to enable operators to configure it, to operate it, and also to provide software. I think one of the biggest advantages for operators is going to be that it's an open source platform. In intelligent transportation systems, historically, they tended to be proprietary systems, and so once you make the investment with a particular system and equipment, you kind of get locked or stuck there. But by providing an open source interface, this would enable you to use a variety of different hardware, but also upgrade your system in the future as new technologies come out. So if you developed a plugin and you're currently using one vendor, that plugin would be able to operate on a different piece of equipment running V2I Hub. And then it also provides that open source interface for operators to develop their own applications in-house or by third parties. And then this is also something that operators may want to consider when they're going into procurement, is specifying V2I Hub, particularly for that interface and for the future potential that it would enable them to develop new apps to that interface and maintain that forward and backwards compatibility. And then a couple just very basic examples to bring it down is the generation of the SPaT message. So utilizing the traffic signal controller broadcast messages that were developed according to the 1202 protocol has enabled interoperability, and we actually had a situation that's being referred to as the first example of plug-and-play technology where the THEA, or Tampa Connected Vehicle Pilot Team, is using Siemens RSUs that were developed to communicate with Econolite controllers, but because Econolite and Siemens both built their RSUs to that same standard, when they came to visit Turner Fairbanks, they were able to plug their RSU into the McCain controller we have here, and it instantly started broadcasting the SPaT and MAP message without requiring any troubleshooting or custom software developments. And so it's been exciting to see how the usage standards actually do simplify and create some consistency. And then I think the other kind of basic example that fits with the SPaT challenge is V2I Hub has been developed to use USDOT's visual map development tool to generate the intersection geometry, and so by using the tool, V2I Hub can actually take the output from it and automatically generate and broadcast the DSRC map message. Some of the adoption and locations that V2I Hub has been used is at Turner Fairbanks and in the Northeast Michigan test bed, at the University of Michigan, Florida's Traffic Engineering Research Laboratory, which actually does the approvals for traffic signal equipment for deployment on roadways in Florida, has given it research approval, which was also utilized for the deployment in Osceola County. And then this coming summer, it'll be deployed in Austin, Texas. And then Siemens Roadside Unit actually uses the V2I Hub software and will utilize the functionality in the Tampa pilot. Currently, V2I Hub version 3.4 has been posted to the open source application development portal and is available for download. And then I think probably the number one requested functionality I hear from operators is for MITs, and that functionality for preemption and for traffic signal priority for transit and different types of vehicles. And so plugins are in the process of being developed and should be released in June 2018 to enable multimodal traffic signal system functionality and posted to the OSADP. An operational data environment plugin to be able to send data to the cloud will be released in June 2018, and then the final version of the software will be posted in September. Support documentation is in draft form, and it should be released in the next couple months. It would include a guide book, plugins, a development guide, software configuration guide, and administration portals for remote access and configuration, and then a guide to provide plugin. And then as a forward-looking item, FHWA is evaluating additional test plans that may be needed to support procurement of roadside equipment, not limited to V2I Hub, but based off a lot of the user feedback that we hear is that's something that operators are looking for that can be passed on to the certification boards to help them identify equipment for procurement and to make sure that it provides the functionality promised. And at Saxon Lab, as part of our goal to support operators, we have a connected vehicle support services. And so if anyone does have questions on V2I Hub or other connected vehicle technologies, particularly in the vehicle to infrastructure area, we're happy to do what we can to support.